Okay, so now we know a little bit more about the basics of probability, the rules of probability. Now we're going to talk about one of the most useful and interesting concepts, which would be conditional probability. Now, this notation here says the probability of event A given event B. So this bar here just means given, and it translates directly to this conditional probability. The probability that A occurs given that B has already occurred. And this actually comes to us from our formula sheet, and I'll show you where this formula comes from. But this notation here, the probability of A given B, is the same thing as their intersection over the conditional, or the conditional event. So, some key words to know if it's a condition, if this is a conditional probability, it's going to say something along the lines of given this, assume this, if this. So look for these key words in order to infer that it is a conditional probability question. So again, this is probability of A given B equals the probability of A and B over the probability of B. And as a result of this formula, and again, this is just from the AP Stats formula sheet, if I want to solve for the intersection, I can just multiply both sides by the probability of B, and I have a general rule here that the probability of A and B is equal to the conditional probability times that condition. So let's actually take a look at this representation. So here's your starting point. Let's say the first event occurs, and we'll just start here with event B. So either event B happens or B does not happen, right? Because of the complement rule. So it either does or does not happen. So that's the first step in our tree. And then the next thing to happen is that A given B. So this is that A occurs given that B has already occurred first, or by the complement rule, A does not occur given that B has already occurred. So we have two pathways now. B occurs and then A occurs, or B occurs and then A does not occur. Same logic is going to follow down here. A occurs given that B has not occurred, and A does not occur given that B has not occurred. So these are the four pathways on our probability tree, and there can be more pathways as well, but most basic probabilities are just going to have these four events here. So from our two-way table, I just said that our probability, we want the probability of A given B. So that's here. This entire row represents the probability of B. Well, that is now my conditional. I'm zooming into that. I don't care about B naught. I only care about B. So in that purple row, I want the probability that A has occurred. Well, when we look at it, in the event B, either A and B occur, or A does not occur and B occurs. So my conditional probability becomes this section here. So I use the complement rule in order to split up the event B. We can see that event B is made up of A and B, and then not A and B. So those are the two events that make up the total event B. And from there, I see that since I just want one of the conditions, I would fill in that box there. So that's why that box represents A and B. Or if we multiplied the probability of A given B times the probability of B, we'd end up with this result here of A and B. And that's a whole lot of mumbo jumbo. It looks weird, it sounds crazy, but once we get some practice in, it's not all that bad, and it's actually one of the more useful aspects of probability. Because most times in life, right, there's a conditional given to us. We don't really, assuming that everyone has this quality, assuming that the coin is fair, assuming that there's no influence, blah, 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 blah. Things like that. So let's take a look first at an algebraic example, and then let's go through and do a word problem. And then this here, again, is called a probability tree diagram. So now our third representation of probability from our Venn diagram, two-way table, and now our tree diagram. And we're going to talk more about this in the following lesson. But for now, let's just focus on these guys. Simple here. Probability of event A is 0.37. Probability of event B is 0.45. And the probability of A and B is 0.24. So it's not a requirement to make a two-way table each time there's a conditional probability. No, I wouldn't even argue that it's helpful. It's just up to you. I'm actually going to work out these first two without my two-way table. So here, again, our general formula is if the probability of A given B is this formula here. So notice whatever comes after the bar is usually that condition. So this here is saying the probability that A occurs given that B has occurred. So here's the probability of A and B over the probability of B. And here, this would also be the probability of A and B over the probability that A has occurred. So I'm going to put 0.24 over 0.37, and we're going to get approximately 0.5333. There's no official stance as to how many decimal points, but 4 just feels comfortable. Same here, we'll have 0.24 over 0.37, and that's going to be approximately, that's going to be 0.6486. And nobody stopped me. The probability of B is not 0.37. The probability of B is 0.45, but the final answer is still correct. So I have these two conditional probabilities. Now, again, it looks really wonky, so I'm going to show you where these came from. So again, I have A, and I have A naught. I have B, and I have B naught. A and B is 0.24, and the total event B is going to be 0.45, so its complement is 0.55. And for A, we have 0.37, and its complement of 0.63. So you can see here that if A is my conditional, I'm ignoring A naught, I'm just looking at A, the event A. So the probability that B occurs given A. So that's here, A and B, over just the probability of A. Vice versa, if I'm looking at the probability A occurs given B, now I'm only looking at this top row, and that's where I end up with the 0.24 over the 0.45. So again, this is just our general notation, and I can figure out the remaining probabilities using my complement rule. And here we go. And so now, because I do have my two-way table filled in, even if it's not one of my basic straightforward probabilities, I can find out any of the conditionals. So the formula is always the same. It's going to be their intersection over the condition. So here, if I want AC given B, that's going to be both A does not occur and B occurs over the probability of B. And that's going to be A does not occur and B occurs. That's going to be 0.21. Over all of B occurring is 0.45, and that's going to be approximately 0.4667. So here's that for you. And notice A occurs given B, A does not occur given B. Looking back at our diagram here, right? These are complements of one another. A and A complement, they should add up to 1. So A given B and A complement given B, notice that this probability here and this probability here, if we add them together, will give us 1. So even with conditional probabilities, we still have this complementary events going on here. So this is an algebraic example, right? It's not too bad. It's just the formulas and where they come from. So again, you're just going to look at the condition, and then from the condition, you're looking at the event that you want. So it's always intersection over the condition. So regardless of what the notation is, intersection. So you'll notice my the upside down horseshoe in the numerator, and then my denominator is always my conditional, and that's given after the bar. And remember, the way I'll figure out my conditional is given, if, assume. Those are my key words there. So here's our algebraic example. Let's spice this up by adding some context. So, for example, a small university takes a random sample of first-year students relating the grade they received in the course and the school that they received the grade from. So our events are already defined. E is that someone receives a grade from an EPS and an engineering and physical sciences course. And L is that the grade is below B. So in my two-way table here, the first categorical variable is the grade level, what grade they received. And the other categorical variable is the school from which they received that grade. There's 10,000 students in this sample, and here are each of my different categories. So here, if I want the probability that someone earns a grade lower than a B, that's going to be event L. So lower than a B, that's this column here. That's going to be 3,656 out of 10,000 students. And that's, as a decimal, is just 0.3656. That works out nicely. Okay, find the probability that someone earns a grade from an EPS course. So now that's going to be the probability of event E, I believe. Sorry, got my notes here too. Well, we can see that those from an EPS course are going to be 1,600 out of the 10,000 students. So that's going to be approximately 0.16. Okay, so now we have PE and we have P of L. So now let's add in those conditionals. Now we're just zooming in. So this first one here says, find the probability someone earns a grade from an EPS course and a grade lower than a B. Sorry, I thought this one was conditional probability. Got too excited here. So they earn a grade from an EPS course and that grade is lower than a B. Going back to my table here. So let's look. Here's EPS and here is below a B. And it looks like their intersection there is going to be 800 out of the 10,000 students. So that's going to be 800 out of 10,000. Oh, one extra zero there. That's going to give me 0.08. All right, so now I've got my intersection and I have my two events, so surely this part's got to be easy here. So find the probability someone earns a grade from an EPS course, given that the grade is below a B. And this one here says, find the probability someone earns a grade below a B, given it's from an EPS course. So I'm going to give you a few moments. Go ahead and try out these problems here. Remember, the numerator will be the intersection of both events, and the denominator is the conditional. So go ahead and take a few moments to try and find these probabilities here. Okay, so hopefully not too difficult. As I've said previously, our intersection goes in the numerator, and then the event goes into the denominator. So we see here that the intersection is 0.08, so that's going to be in the numerator for both, and then our probabilities of the conditionals. So we get approximately 0.2188 for this situation here, and then about 0.5 for this situation here. So not too complicated, you just need to define your events, and then utilize the formulas to find those conditions. Now, I did want to talk about the math behind why this works, because there is an alternative to it, right? If I want the probability that given the grade was below a B and they got the grade from engineering and physical sciences, if my conditional is just 3656, the below a B, then that's just 800 out of 3,656. And when I do that, I get the same answer here of 0.2188. So mathematically, and vice versa, if my condition is EPS and I want that they got below a B, so of these three events, that's the 800 over 1600. Again, we can see 800 over 1600 gives us 0.5. 800 over 3656 gives us that approximate 2188. So mathematically, all that's happening is this here. Because probability, right, this came to us originally as a fraction, and since these both share the same denominator, we can drop the denominators, they cancel out, and we end up with the same result. So just a way to check your work. Ideally, the points that they're looking for on the AP exam are that you've defined the what you're looking for. So our event here was P, E given L. We show some work, and for us, our work is going to look like these steps here, and then a final answer. So those three components are generally what they're looking for on the AP exam when they're looking at conditional probabilities. So in the next lesson, we're going to talk about probability tree diagrams, continuing our discussion on conditional probability.